The last type of problem I want to look at today is going to use something called the remainder theorem. And really, I think this is one of the neatest things about synthetic division, how this works. Here's our remainder theorem. To evaluate a function's value, when x equals a, find the remainder when dividing by the factor x minus a. So in other words, if we're trying to find a function's value when x equals a, we could plug a into your equation. And sometimes that gets really tricky. Sometimes it's really easy to mess up a negative along the way. Another way to do that is to just divide by x minus a, which is a lot easier when we use synthetic division. And whatever our remainder is tells us our answer. Here's an example. And I'm just going to do one of this example also, because again, it's synthetic division. The only thing we really need to find is what our remainder is. So if you need to watch this video a second time, that might help you if you're still not really sure of what's going on. Otherwise, I'm just going to do this one example. Okay. If p of x is my polynomial equation, so if p of x equals x to the 5th power minus 3x to the 4th minus 28x cubed plus 5x plus 20. What is p of negative 4? So this is kind of a prime example of what I was just talking about. We could, in theory, plug negative 4 in. Take negative 4 to the 5th power. Take negative 3 times negative 4 to the 4th power, and keep going. That gets really tedious. We might have some really big numbers that we're working with, and it's really easy to mess up negative signs along the way. Our remainder theorem makes this a little bit easier. Let's use our synthetic division. So first thing, we write our coefficients. When our equation's in standard form, we have 1x to the 5th, negative 3x to the 4th, negative 28x cubed. I don't have an x squared term, so 0, 5x, and 20. I want to find my function's value when x is negative 4. So negative 4 goes in my box. But then we do synthetic division like we normally would. Okay? Just a couple things to note. Remember, we need to have the 0 here because we don't have an x squared term. And I'm evaluating when x is negative 4. Negative 4 goes in my box. That sign of my x value that I would plug in is what goes here. Okay, synthetic division, we bring down our 1. 1 times negative 4, add down. Negative 7 times negative 4 is positive 28. We add down. 0 times negative 4 is 0 times negative 4 again. 5 times negative 4. We get our remainder of 0. Now, it doesn't matter what all of this stuff is. We're just finding our function's value. It's just the remainder we look at. So 0 is our final answer. Kind of a neat way to figure this out. So that's a lot nicer than having to figure out what is negative 4 to the 5th power? What's negative 3 times negative 4 to the 4th? And so on. Just that remainder we need to find.